Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Chris Kryko's insightful piece, The Essence of Successful Abstractions. Simply Mathesy. It's a fascinating look at how we manage complexity in software development, especially through the lens of types and abstraction.
Right. I've been meaning to read this. The title itself, Simply Mathesy, sounds intriguing. What's the core argument?
Essentially, Kryko argues that complexity in software is unavoidable. It's not about eliminating complexity, but about carefully managing and isolating it. He uses Fred Hebert's quote about complexity having to live somewhere as a springboard. Hebert's point is that whether it's microservices or other architectural choices, complexity doesn't vanish. It just shifts location.
So how does this relate to types and abstraction? I see.
That's where it gets really interesting. Kryko applies Hebert's idea to type systems. He says types, like microservices, represent complexity. The key isn't avoiding types, but using them effectively to encode knowledge about the system. A robust type system lets you write down and enforce contracts about how different parts of your program interact.
Interesting. So a strong type system isn't about adding constraints, but about making explicit the existing constraints?
Exactly. It's about making the implicit explicit. He uses Rust as a prime example. Rust's borrow checker enforces complex rules about memory management, but it isolates that complexity within the type system and unsafe blocks. This allows developers to focus on the application logic, rather than constantly worrying about low-level details.
That makes sense. It's like, shifting the burden of managing complexity from the developer's brain to the compiler. But what about languages like JavaScript? They're dynamically typed.
That's where TypeScript comes in. Kryko argues that TypeScript, even with its sometimes complex type definitions, doesn't add complexity. It reveals it. By explicitly defining types, you're bringing hidden complexity to the surface, making it manageable. It's a tool for grappling with existing complexity, not creating it.
So it's a trade-off. You gain the benefits of static typing, but you have to deal with the complexity of defining those types. But isn't that complexity still there, even if it's more explicit?
It is, but it's contained and controlled. The article emphasizes that the goal isn't to eliminate complexity, but to isolate it. Rust isolates memory safety complexity. TypeScript isolates type-related complexity. This isolation makes the code easier to reason about and maintain. It's about making informed choices about where complexity resides.
I see. So the essence of successful abstractions is about strategically placing complexity, not eliminating it. It's about choosing the right tools, types, tests, even microservices, to manage that complexity effectively. It's a really insightful point.
Precisely. And that's why Kryko's article is so valuable. It challenges the common notion that simplicity is the ultimate goal in software development. Sometimes, controlled complexity is necessary for building robust and maintainable systems. It's about making conscious decisions about where that complexity lives and how it's managed. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of software abstraction. Have a great day.
Bye-bye.